Good morning, everyone. Today we will discuss the third module that we started in previous session with linked lists. How do we represent them in linked list? This is a simple linked list where we try to justify what is this info data and why this link is needed and why this null is needed. Also, we discussed it's a static and dynamic representations in memory. If it is static representations, then it will use two single dimensional arrays which will kill the unnecessary amount of which will kill the memory which is unnecessary, and when compared to this dynamic memory, in the dynamic memory representation of the single linked list, it will occupy only the memory which is needed. That's all. The other parts of the memory which will not needed for the linked list can be used by some other parts of the program, by some other programs. We discussed the different operations like traversing, insertion, deletion, reversal, copying, cloning, etc. So in insertion also we discussed about how do you insert at the beginning and at the end and at the specified node. If it is at the beginning of the linked list, this is the logic that is going to be useful, and if it is at the end of the linked list, this is the logic that is going to be applicable, and if it is in between the linked list, this is the linked list. This is after a particular node, and this is going to be before a particular node. Also, we discussed how do we reverse the linked list with this animation and with this set of instructions. Later we discussed about the deletion of an element from the deletion of a node from the single linked list, where we try to delete at the beginning in this case, or you may delete it at the end, or the other last functionality that we discussed was like how do you copy or clone a particular single linked list. So that is what we discussed in previous class, and in today's session we will start up with the circular linked list. It is almost similar to singly linked list, except that the circular comes into picture. The same functionality will be implemented, except with some pointers that is going to be arranged from the last node's next pointer will be pointing to the very first node. So its next element in the sequence and the last element has a link to the very first element. So that means circular linked list is similar to the linked list except the last node. So if I have a linked list which can do the functionality of then why do I need a circular? In a circular linked list, to access any node of a linked list, we start traversing from the first node. Say if I have to traverse the third node, I have to start from first node. But after traversing the third node, if I have to traverse again the first node, then it is not possible. So that is when we are in the middle of the list, it is not possible to access nodes that precede the given node. So that precede the given node are the P1 and P2. After moving to the P3, if I have to access the data that is present in P1 and P2, it is not possible. So that is why if it is circular, I can go again from the last node to the first node, and again I can traverse all the preceding nodes. So that is the main advantage of this circular linked list. So next we will move on to the operations, where we try to create and insert the data into the single linked list. If the linked list is going to be empty, then by itself it is going to be the null. No data, no links will be present. If it is going to have at least one element, then in that case the first and last node to be this one, where the last node is going to be pointing to itself as it is going to be the first one, and it starts with this particular thing. So that is what the logic for inserting into an empty list. But if you are already having some nodes, here the last is a necessary pointer, because you need to identify which one is going to be my last node within this given circular linked list. So in this case 8 is my last and 6 is my first. So if I have to insert at the beginning the newly created node 10 to the existing linked list 6 followed by 8, then in that case what do I need to do is, earlier this node 8's next was pointing to the 6, but now new after insertion into the new node, 8's next node will be pointing to the newly created node, and the newly created node's next pointer will be pointing to earlier first node. So that is the simple logic to justify how you are going to insert at the very beginning of the linked list. Now the third case is second case is at the end of the list. So if I have to if I have to insert this 10 node at the end of the list, then I have to move from the beginning to the end of the circular singly linked list, or move up until the last position of this circular linked list, and then insert the node. How do I insert is, earlier 8's next pointer was pointing to the first, but whereas in this case now 8's next pointer must point to the very first node, and this newly inserted node's next pointer must be pointing to the first node of the linked list. So these pointer and this pointer must be rearranged, and also the last pointer must be rearranged. So totally 3 necessary basic operations must be needed. One for making this arrangement, and another for making this arrangement, and another for making this arrangement instead of this one. So that is insertion at the end of the linked list. So before we'll move on to the other topic like deletion, we'll conclude with insertion in between the linked list. Say in between can happen with respect to index of the linked list, or it can happen by comparing the node's value. Say if I have to insert after the node 8, then in that case it is very simple. Or after the second node, I can keep the total number of nodes, and then I can keep on traversing from the first node and the second node, etc. If I have to insert after the second node, I will make the pointer arrangements. So if I have to insert after the second position, or if I have to insert after the node with whose data value is going to be the 8, so then in that case, so the 8's next pointer must be pointing to the newly created node, and this newly created node's next pointer must be pointing to the earlier 8's next node, or the next node within this linked list. So the last need not be changed, but if it is after 10, it will be similar to inserting at the end. So this logic must be applicable. So before we proceed to the deletion of elements from the circular singly linked list, we will try to justify it with a program where we try to insert at the beginning, insert at the end, insert at any particular position. Now we will move on to the what you call the C program execution environment using VS Code. So we'll move on to this program explanation, wherein we try to justify how the insertion operation is being done. I'll explain this program in detail, and a few functionalities which are similar to in the deletion will not be explained again. So I'll try to explain in detail here itself a few concepts. Now as you know, the why stdio.h is needed. I need not explain that. Now here this is the instructions which is going to be the struct node and two member variables. One is the integer data and the other one is the pointer variable which points to the same structure kind. So this will represent my circular linked list, wherein it has got the two member variables, and now starts with add to empty list. If the linked list is empty, then so this function is only for the empty list. So if the last is by itself is going to be null, in the sense that no memory is being allotted for that. So last null itself is going to be, then only it is necessary to do the adjustments here. So if it is say in that case, create a node dynamically. So for this you create a temporary pointer, a temp pointer variable which points to the struct node type, and you allot the memory using the malloc. And then for this temporary variable you assign the data that is being passed from this function to the temp data. So this data is different from this data. This assigned data is being passed to this function, whereas this data is going to be the member variable of this temp variable of the structure. So last equal to temp, because the last equal to null, as this function is going to be applicable only if the circular singly linked list is going to be empty, and then return the last. This instruction is necessary because last next, to make it circular, this instruction is necessary. So this is add to empty, and if it is the other function, add at the beginning. So if it is not null, or if it is equal to null, in the sense like if the circular singly linked list is going to be empty, then call the function which will add the or create the circular linked list with the very first node. If it is not empty, then you create a temporary node, assign the data, and make these arrangements where temp.next equal to temp next is last next. So temp next is last next, where earlier last next used to point to the very first element, and now last next is going to be the temp. So that is adding at the beginning. So these three instructions will make the adding at the beginning. If I have to add at the end, then first find out whether it is empty. If it is empty, then call the add to empty function, which will create the very first node. If not, then you try to allocate the memory using the malloc to this pointer variable, and try to do these instructions. So before proceeding further, so you have to compare these 3 lines of instructions with these 4 lines of instructions. As you see here, the first instruction is assignment of the data, assignment of this data, and the second instruction is the last next is being assigned to temp next, which is going to be the same as the previous case. The third instruction is going to vary. So the third instruction is, this was last next is temp, this is for insertion at the beginning, whereas in this case last next is going to be the temp. Last next is going to be the temp, which is similar to here, but in the last instruction is going to vary here. Last equal to temp. If you do this instruction, then this will become add at the end. If this instruction is not there, if you just simply return the last, then it will be insertion at the beginning. If you are not going to assign the temp to the last and return, that makes the difference. So assign the temp to the last, as it is going to be the end. So as it was pictorially explained, so it is applicable here. And the other function is add after. So what do I do here is, as it is similar, find out whether it is empty. To the empty list I cannot add after. Now I have to add at the very beginning, so I will just simply return it as null, as saying that insertion is not possible. Otherwise, you create a temporary 2 pointer variable which are of the type struct node, and P is going to be like, initially it will be having the second node's address, last next. Do this set of instructions, like it will be starting with if condition. So if P data until the present node's data equals to the item. So once I find this item within the linked list, then I will start inserting. So how do I insert is, create a pointer variable to which points to the struct node, and allot the memory, assign the data, and then what do I do? I need to do is, the temporary next is going to be P next, and P next, because the P data has been matched with the current item, so I will make temp next equal to be the P next, and P next equal to temp. So thereby I insert this temporary node in between. So if it happens to be the last, if P equal to the last, so last equal to temp, and return the last. If it happens to be like you are inserting at the last, then this if statement is going to be the necessary instruction. Otherwise, it is sufficient. So if this instruction is going to fail, or if from within this while loop, if I am not able to return using this instruction, then in that case, not present in the list. So not present in the list, I will return the original list, stating that the given item is not matching with any of the data that is present in the existing linked list. So traversal or display traversal or displaying the current linked list is, so if it is going to be empty, then say that it is going to be empty. Otherwise, assign the second link as p equal to the, or point to the first node of the list, and then start traversing to the next, print it, traversing to the next and print it, traversing to the next and print it, until you reach the starting node. So starting node, you keep on printing it. So that is how you are going to do. So here in this case, first I will insert 6, and at the before 6 or beginning of the 6, I will try to insert 2 and 4, and after 6 I will try to insert 8 and 12, and at the end I will try to insert 8 when the after the linked list node consisting of 8, I will try to insert new node with a value of 10. So we'll try to execute this program and find how the output looks like. Let me open the output window, where you will be able to see the output window, where before to 6 and after 6 you will be able to insert the elements, and the last one will be adding after the node consisting of 8. The 10 is going to be inserted. Yes, here if you are able to observe, so 6 was the first element that was inserted, and after that these two were inserted before to 6, and 8, 10 and 12 were 8 and 12 were inserted after the 6, and the last instruction was, see, if you observe here in the program, so the 10 is being inserted after 8. So if you observe the output window here, 10 is inserted after 8, but 8 and 10 and 12 were inserted. Okay. So that is what the insertion operations with respect to circular linked lists. Now we'll move to deletion of a node within the circular singly linked list. So in this case also we'll be having 3 options: 1 to delete at the beginning, to delete at the end, and to delete in between. So we'll start with the deletion of the node at the beginning. When I have to delete at the node at the beginning, here in the deletion case I need 2 pointers, the previous and current pointers, which will be pointing to the existing circular linked list, which will be useful for traversing the linked list. So keep the current pointer fixed, pointing to the very first node. So in this case, say current pointer here, so here I have a linked list of 10, 20, 30, 40. This is the circular linked list. So here I have to delete the very first node. So this node needs to be deleted. So after deleting it, what is the logic is, I have to keep this current node which will point to the very first node, and then move the previous until it reaches the last node. Previous node will be pointing to the last, and current will be pointing to the very first. So I have to write that particular logic. Once the pointer previous reaches to the last node, I have to do 2 instructions. One is previous next. Previous next must be pointing to current next. Current next is pointing to the next node within my linked list. Next node to the very first node, which needs to be deleted. If it needs to be deleted, earlier this was pointing to the first node, but now this needs to be pointing to the next node from the first. So that is why I assign current next to the previous next. So by that it gets deleted. And also earlier head was pointing to very first node. Now head must point into the second node, or head must point to the next. The previous next. So likewise, if you do this instruction, then that is sufficient. So with that we get the new linked list as 11, 22, 33, etc. So that is deletion node at the beginning. If I have to delete the node at the end, what do I need to do is, so similarly to previous case, I need to have 2 pointers, current and previous pointers. Move pointers such that next of previous is always pointing to the current. Keep moving the pointers current and previous until current reaches the last node and previous is at the second node. I'll repeat, move both the pointers such that next of previous is always pointing to the current. Keep moving the pointers previous and current until current reaches the last node. So what do I mean to say is, when current points here, previous must be pointing here. So it is in short that explanation was. Once the pointer reaches the last node, once the current pointer reaches the last node, yes, what do I need to do is, previous, this is the previous, earlier this was pointing to the last node was pointing to here, this was pointing to here, but now what do I need to do is, I have to delete this particular node. So to delete this node, earlier this was pointing to this node, so this pointer must be rearranged to current next. The previous next must be pointing to current next and head must be pointing to previous next. So with that, with these two instructions, this will get deleted. This will get deleted. So that is the simple logic applicable for deleting a node at the end. We'll exhibit this with a program. Let me go through the other where you are going to delete nodes at a given index. Say here in this linked list, I have 4 elements. If I have to delete the 5th element, it is not possible. So that is why in this case, I need one more function in addition to earlier explained functionalities. So where it will find out the total number of nodes within my circular linked list and it will report back how many number of nodes are present. So in this case, so as always with respect to deletion, I need to have previous and current pointers which will facilitate us to traverse the list. So such that previous is one position, as earlier case, here also you need to have the current and previous pointers. So what do I need to see? It is very simple, deleting nodes at a given index. So what do I need to do is, so first find out whether, say if I have to delete this particular 22, find out 99 is matching with 22 or not, 11 is matching with 22 or not, 22 is matching with 22 or not. Once it matches, what do I need to do is, this pointer must be pointing to this. So this pointer must be pointing to next, then it gets deleted. It gets deleted. So we'll try to go through the C program where we'll try to exhibit these 3 deletion functions, delete at the beginning and at the end at a particular index through a C program. Now let me move on to the C program environment where we will try to justify it with a C program. The C environment is, let me open the program. Yes, this is the deletion function, circular linked list deletion function. I'm not going to explain again all the lines of code, but this code is going to be for a structure which will define a circular linked list, and insertion as earlier explained, because you need to create the values and the display is just simply traversal of the circular linked list. This is the newly added function which will keep on counting the number of nodes within my linked list. It will start from the beginning until it reaches the end. Once it reaches the end, it will report back the count or the total number of nodes in the given circular linked list. Now what I have to do is, I need to understand how do I delete the first element. So first element is, first I will assign, I will create the next and previous pointers which will point to the same, and if the linked list is empty, then I cannot delete and I will return back by stating that there are no elements in the given circular linked list, hence it cannot be deleted. Now check find out if there is exactly one single node. In that case, head will be, if you make head to be null, then that element will get deleted out. If not that case, then you have to keep moving until, so traverse to the second node until you reach the second node. Once you reach the second node, you have to perform these two instructions. One is previous equal to previous next and next equal to previous next. If you assign the same address to the previous and next, then the nodes get deleted. What is that it is going to be deleted is, it is going to be the delete first item. So by assigning previous next to both previous and next pointers, then it will get deleted. So yes, and now previous is the last node and next is first node of the list. First node of the link address, put it in the last node of previous link. So this instruction is necessary. Previous next equal to next list, and make the second node as head node. So by that we delete the very first node. How do I delete the last node is, as I require current, previous, and I will require one more temporary variable. So if the by head itself is null, then it indicates the linked list, circular linked list is empty. Find out if it is going to have exactly one single element. Then in that case also you try to apply the same logic. Only logic that changes here is in these 5 instructions, where if it is equal, current next is equal to head. Once you reach the last, if it is equal, then it might have been the last, but here it is not equal to. If it is not equal to, then you keep on moving to the last node of this linked list. So you observe here and here within this while loop, you keep on moving to the last node. So here in this case it is going to be keep on moving to the last node head. So feel the difference from here to here. So previous equal to current and current equal to current next. So what do I do in this instruction is move first node to the last previous. So after that what do I do is, so just simply previous, so here previous next equal to current next and head equal to previous next. So and then free, in whichever program you use the dynamically memory allocation, either malloc or calloc or calloc, you must use the free functions, otherwise it will go wrong. Yes, this is at a particular position. Or the first few things are going to be the same, except that the index is going to be captured, is going to be matched with in length. Say here, why do I find this condition is, say if I have only 4 nodes and if I have fed the index to be 5, then I should not go wrong. So that is why, to be safe, on the safer side, I will find the total number of elements within my circular linked list, and then I will try to and then I'll try to delete the element. So within this while loop, I will be deleting the element. How do I delete is, if the index is equal to count, then one simple instruction is previous next is equal to next. So I need to have this instruction, this free, because this is going to be dynamically allotted memory, so that is why I need this free. So in the program itself, I had given the input here, the 11, 22, 33, 44 and etc. I had given, and if you run this program, you may be able to observe the output. Let me run the program and find out what the output will look like. Yes, as you will be able to observe here, the initial linked list is going to be like this. I think it has printed the 99 always. After deleting the element at the, I think I have rerun the program with the rerun. Then now I will be able to observe here the initial linked list is 99 followed by 11, 22 etc. up until 66. Now deleting at the 4th index. At the 4th index, what the element that I had was the 0, 1, 2, 3, 4. 4th index I had 44, which was deleted, and the resulting one will be excluding 44. So after deleting the, so here. After deleting node at index 4, that I will get it here. After deleting the very first node 99, I will be getting this output. After deleting the last node 66, I will be getting like this. So likewise, the deletion at a particular index, first node and last node, are exhibited through this. Let me move on to the other parts of explanation. So after concluding with the circular linked list operations, we'll define the header linked list and followed by what do you call the ground header linked list. Already circular linked list was explained, which will conclude conclude with this explanation. So what do you mean by header linked list is it is a linked list which always contains a special node called as header node at the beginning of the linked list, as we already exhibited here. Only thing is that header node will be associated with, say, ant, pat, cat was the nodes. Earlier we took integers, now it is going to be strings. So a header node will always be there. So that is why you call it as the header linked list. Then followed by grounded header list. What is grounded header linked list? Grounded header list is a header list where the last node contains the null pointer. If the last node contains a null pointer, then it is going to be grounded header list, or a normal linked list with a header node. And if it is going to be a circular linked list, then it is going to have a pointer to the very beginning. So that's all the difference between them. So maybe in the next session we'll discuss the doubly linked list. For the day, we'll wind up with respect to circular linked list and header linked list explanation. I expect you go through the programs of header linked list. We'll wind up for the day.